Happy Monday. Welcome to the show, Dave. For our listeners, it's my privilege to welcome Dave Mariani, who is the CEO and founder, as I understand it, of AtScale. And we're going to talk about a number of issues around the semantic layer and such. And we look forward to questions for those watching the stream today. Welcome.
Hi, Matt. Thanks for having me. And I'm the CTO and
CTO. Okay.
co-founder of AtScale. I was the CEO for the first 5 years, but for the last 3 years, Chris Lynch has been our CEO.
And so tell me, I was actually kind of doing some, online stalking to find out more about you and more about your history. And one of your articles I found on LinkedIn, I think it was called "The '90s Called," and they want their OLAP back, basically. And that
Mhm.
that was interesting because I've sort of learned more about OLAPs over time because I think the term has been co-opted to mean something different now than it did a few years back. So back in the '90s, the OLAP. Well, I'll let you explain that. That recently the OLAP has just come to mean any online analytics system, and back then it meant something
Mhm.
different. And I think that's very closely related to what to your motivation for founding AtScale, actually.
Yeah, it's interesting. The history, I'll show my age here, Matt, for a second, is that, began my career in the very late 80s, and so the 90s was where I was really introduced to data and data warehousing, which was very nascent back then. And SQL was the standard for writing queries against databases. But very early on, to make data more consumable by the business, OLAP was born, and there were business intelligence platforms like Business Objects who really sort of coined the term semantic layer with the business universe. Cognos, MicroStrategy, all SQL Server Analysis Services, which was my favorite. And what people didn't realize is that, I mean, people today think of OLAP as sort of a performance optimization technique.
Yeah.
It's something to make queries go faster. And really, that's a big key part of it was making sort of queries speed of thought, and that was always one of the key benefits of OLAP. But really, what I thought was as important, if not more important, was the semantic layer part of OLAP. The whole idea of measures and dimensions and
Yeah.
hierarchies, and basically that translation layer that takes sort of technical data that's stored in tables with relational databases and joins and all that kind of stuff that really requires somebody to be a database expert to be able to run queries and puts it into business terms that allow people to consume it through drag and drop through business terms that they understand, like revenue and location and product, without having to understand how that data got there. So really, those business intelligence platforms, those were all like that's what really I think really made business intelligence really grow and be really popular to expand the use of data to more than just database experts. But then data got big.
Yeah.
And when I was at Yahoo, I was running analytics for Yahoo this is around 2010, 2012 timeframe. And we were one of the big internet companies, and we did have big data, and our data was so big wouldn't fit in Oracle. So that's why we invented Hadoop. So that's where Hadoop incubated and came from, was out of our platform team, our data platform team at Yahoo. And but I still used OLAP there because nobody could understand Hadoop. Nobody could actually run queries against Oracle. So we created I created this very large SQL Server Analysis Services cube when I was at Yahoo. It was 24 terabytes. We wrote a bunch of white papers. A lot of people sort of copied or looked at our techniques for how to scale OLAP to that size, which was unheard of, still is unheard of. I think the biggest OLAP cube out there is probably 5 terabytes, even today. But Matt, it was crazy because keeping that thing running and fed with data on really just a fraction of the data that we needed. I could only hold 3 months of data at a time. But I tell you, my users loved it, and the reason why they loved it is that it was business friendly, and they created these solved these business problems that I could never understand in a million years for display advertising and the like. And that one of the cubes, we did some attribution, and it generated $50 million of additional revenue to that business every year. And that was just with one cube. So it was very clear, Matt, that the semantic layer and that model was really, really important in terms of making data accessible to everyone. And for me, at Yahoo, I had one of everything in terms of consumption tools. I had Tableau, I had MicroStrategy, I had ClickView, I had Excel, of course, everywhere. And then I had a bunch of custom applications for publishers and advertisers. And so there's multiple consumers. They all wanted one view of the data. They wanted a business-friendly view of that data, but it had to scale. And that's where I ran into troubles, is on the scale side. So back to today, I think that what we ended up doing to solve the scale problem is we ended up throwing out the semantic layer. And we went back to square one, where SQL was the only interface to ask questions of data. And I think when we did that, Matt, we lost a whole bunch of people who could ask questions, because OLAP went out with that, because it didn't scale anymore. It went out with the sort of cloud data platform revolution, and we sort of forgot about it until we really focused on bringing it back, but modernizing it for today's data scale and today's data platforms.
Yeah, I actually have some relevant experience, I think, in working without a semantic layer and without an OLAP cube. And this is in one of my previous engagements. I won't give too many details, but in a job or with a client. And what would happen with this particular company I was working with is that you would have all these analysts who were subject matter experts in different parts of the company. And they would write these super complex SQL queries to get the company had multiple types of revenue and profit that they would recognize. There was like revenue before marketing costs, revenue after marketing costs, and the formulas to calculate these things were super, super complex. And they were defined by the business units. But the problem was that, marketing would have this really smart analyst that would run a super complex query that only they really understood, that, had like 5, I don't know, layers of CTEs in it or something like this. And then somewhere across the company in inventory, they'd run similar queries and, calculate, okay, how much revenue we bring in on sales. And the numbers would never match, because there would be like some minutia of something in the query that wasn't quite consistent between the two. And who knows if even the business, definition of those metrics had defined things down to that level of detail. There were all kinds of like, okay, do I take into account estimated fraud losses in this query or not? And that would cause differences in the metrics. So maybe you can comment on that a bit, because that's one place where I've seen this be a huge problem. It's not just accessibility of the metrics, but consistency is a massive problem.
Consistency is a massive problem. So I'll give you an example with the Yahoo business. I mean, Yahoo really ran the business on page views and clicks. Page views in the form of, we produced a bunch of web properties like Yahoo Finance, Yahoo Homepage, Yahoo Sports, and then we monetized it by running advertising, search and display. And so the way that we tracked all that was, who's viewing what, that's a page view, and who clicked on the ad, that's a click. And so Matt, to your point, it's like, that seems like a really simple thing, right? Did they click or did they view a page? It's actually, there's enough nuance there that everybody had their own numbers for those two core metrics, because some people would calculate it, they'd all calculate it in the BI tools. So the MicroStrategy people would calculate it, and they would start collecting the data at 9 p.m. the previous night, and then cut off at 6 a.m. So they didn't have so it was always sort of a different time when they started collecting that click and that page view data. And then sometimes they would, in Tableau, the people would do a total clicks, not a unique clicks. And unique clicks are really important, because you need to know how many times a single person is clicking, not just how many times they did click.
Yes.
And so some people would mix up uniques versus total clicks. And so, and then there was different calendars. So some people wanted to run things on a retail calendar, which is different than a fiscal calendar, which is different than a Gregorian calendar. And so you could see that you can get into trouble really quickly, and we did. And so, I had to staff a team. We called them a data quality team, that went through and just policed all this stuff. And it was like, it's with 7 people that just spent their time reconciling reports and getting people to stay to get in line. And so that was really the impetus for me to say, this is ridiculous. There needs to be a technology to solution to solve this. And there really wasn't at the time. And there's and it wasn't, it's like people were still, suffering. And, I think that Matt, there was like, it really took sort of like the self-service revolution came upon us, and the business took things in their own hands. And it took a while, I think, for the business overall, meaning the organizations, to figure out maybe we swung the pendulum too far in that other
Yeah.
direction.
Yeah.
And now nobody trusts the data, and everybody's fighting over the numbers.
Yeah. And I want to relate this to a lot of discussions we've had on LinkedIn and Twitter, just kind of the data sphere arguing about things. Over the last year, there's this whole like modern data stack is dead crew out there arguing that this whole concept is broken. To me, most of the critiques of the modern data stack, by which I mean, you have ingestion tools, and then you're typically using a cloud data platform like Snowflake or BigQuery or something along these lines. And then
Mm-hmm.
you have various other tools that maybe run queries inside that system. Most of the critiques of the modern data stacks come down to people are deploying it in too haphazard a fashion. In other words,
Mm-hmm.
it's just kind of like we're talking about, where there's no metric consistency. People are building out all kinds of queries, and there are no training standards. There's no harmonization of data. There's not a lot of work done on data quality. And then the second big critique is that you easily on the modern data stack, because it's not fixed price contract based like old days of Teradata say you just buy a system and that's what you're going to spend, and it does not scale. You can spend a lot of money very quickly on the modern data stack if you're not careful. So I'm wondering, maybe you relate the semantic layer to these two problems. So just haphazard, lack of standards on the modern data stack, and then cost. How do you interact with those two maybe critiques?
Yeah, there's a whole topic of FinOps around this whole area. So
Yes.
I find really fascinating. But look, it's let's talk about the models of how organizations typically organize their teams to produce analytics or enable analytics. You have the old days where it was all centralized. IT owned everything, and the business got what the business got. And if the business wanted something new, they went to IT, and IT would work on it, and it would take months later they get their answer. That obviously didn't work, and so we moved, and the pendulum, swung to the other direction, where the business sort of started to do their own analytics and do their own data pipelines, which created a lot of the chaos about for what you see. We've seen customers do a blend where, rather than data mesh, if you typically look at that sort of definition, it really doesn't have a central team, and I think that's wrong. So what I've seen customers really be successful is implementing a hub and spoke style. Gartner calls it a data franchise model, where you have a franchise owner and a franchisee and a franchisor. And in any case, however you want to call it, there is some central team that is setting policies, that is doing some of the common stuff. Maybe they're doing the basic pipeline stuff. They're definitely choosing the data platforms being used and the tools being used in the ecosystem, and setting the rules of the road. And then you can have the domains, the business domains, go ahead and have the autonomy to create their own data products within those sort of standards. Now, where the semantic layer fits in that is that it's, without a common language, people are still going to create their own business definitions of common business terms, and you're still going to have that chaos. So where I think the semantic layer fits really nicely is that it becomes that, it becomes the Rosetta Stone. It becomes the common way that people can describe the business, through a semantic data model. And those semantic data models are supported by things like conformed dimensions. So you can have one definition of what the product dimension looks like, and what a product hierarchy and how it rolls up. You can decide to have a time dimension, and it could have different flavors, but it still is. There could be a fiscal, and there could be a calendar, a regular Gregorian calendar, but they're still consistent, and the numbers will be consistent between them. You can create an organization, of course, dimension that's going to be used, so people are going to report numbers consistently across that. And you can also centralize calculations, but it enables people to, and enables these domains to share their sort of IP, their IP meaning their knowledge of the business, and it allows them to encode it in a way, in a technical way, that can be shared with other domain teams, which may not understand that domain's business. So if I want to do an ROI by marketing campaign, that involves the marketing team and the finance team because the finance team is tracking the costs. So I can then allow those teams to collaborate through the semantic model to be able to calculate and create a model to express and calculate that new metric. And so I think if you, so for me, what I've seen work is hub and spoke supported by a semantic layer. And it gives you the best of both worlds. You got standards, so there's rules of the road, but you also have autonomy in the business, so they're not constrained and waiting for IT to hand them the data.
This reminds me of a conversation that Joe and I had with Bill Inman. It was probably like a year and a half ago,
Mm-hmm.
and we were actually people had kind of assumed that he was against the data mesh concept, and he said on when we talked with him on the show, he said, "Well, I like the concept, but you still need some centralization. In other words, all these teams are generating their data, they're responsible for their data, they're sharing it, but somewhere centrally, you need to have like a standard view or standard modeling of that data as it comes out of all these different sources as you're joining across them and building metrics that require joins across different teams and such."
Mm-hmm. Mm-hmm.
Maybe I can follow up with this question: how is the current semantic layer concept related to or different from the Bill's original data warehouse concept?
Yeah, it's really interesting because so we just had the Semantic Layer Summit last week, and one of my sessions was with Bill Inman, and we talked exactly about this. It's like because there's been controversy over the years between the Inman and Kimball style
Yes.
of doing data, and and Bill describes it as data warehouse versus data mart. Data warehouse being Inman style, data mart being Kimball style, and it's I never really sort of understood the distinction, honestly. But what Bill's point is like, you do need somebody, some centralization, some governance, somebody who's defining the rules of the road. And he saw that a strict data mart kind of a process where you let the business units create their own data marts are really antithetical to that common view of the business. So look, I think that so I tend to believe in that that I not tend to believe. I do believe that you do need to have, and don't call it a central data team, call it a center of excellence. You do need to have, and that center of excellence has membership that includes the business, obviously, and IT. It needs to be a cross-functional team, but there does need to be some there needs to be standards. Otherwise, it's just back to chaos, and it's actually worse chaos than we had before. It's like you can't have everybody creating their own data products in their own view using their own tools. There's absolutely no economies of scale. And so, Matt, when we get back to the cost perspective on that, you cannot control costs if it's anything goes. You need to have some way of knowing and being able to allocate compute resources to different domains and give them a budget. And you can't do that if there's no standards for how that consumption is used, or even what type of consumption is used. So I just don't think it can work as a pure decentralized model. So if that's what data mesh means, that can't work. But I like the concepts of saying that give autonomy to the domain teams who understand their business better than any IT person will ever understand. And there's no way that any single person can understand every single line of business in an organization. So you got to federate that type of knowledge and work, and you give them the right tools to do that. But it's the tools that are under that been established by some type of team where they've picked that tool set, and then those domains can operate within those confines.
Yeah, that's fantastic. And I think I really liked what you said about center of excellence connecting IT with the business, because I think that's one of the common problems I see is that you have a really competent IT team, but they just have difficulty communicating with the business side of the house. Like they just, I don't know, like we nerds, sometimes have trouble communicating with people who come from a different perspective, who are just thinking about P&L and not thinking about the details, the technology they're using, and they're thinking about marketing budgets and marketing campaigns. Do you have any broad general thoughts about how we facilitate communications between the business and the IT side of the house to build that
Mhm.
center of excellence?
Yeah, Matt, when I was at Yahoo, what I was and this is what really sort of like it really nailed this idea in my head is that um, if I gave the business a data set, and obviously they're telling me what they need to see, but those things and what they need today, by the time you deliver it, it's changed, right? Because the business is constantly changing. So for me, what I want to do is give them all the data that we were collecting, give it to them in a fashion. This is where OLAP comes in, where they could slice and dice any way that they can imagine. And so give them a data set that's as flexible enough, where the data model is flexible enough that they can sort of create and answer almost any question that they have. And if they can't answer the question, it's because the data is not there. And then they'll go and get the data and then make that part of that model. And so what I found is by doing that, and again, working in conjunction, me and IT, and working with the business units, they came up with stuff that I could never have imagined in a million years. And because they had the business problem, but they had the tools to solve it. And so they didn't have to come back and ask me for specifics, reports, or new slices of data, because they could do it their own. So to me, that is true self-service. Self-service is not forcing your business user to become an IT expert. That's not self-service. Self-service is giving them a flexible set of data, a data in a flexible form where they can answer virtually any question they have on their own using the tools that they already understand and know how to use. So, and to me, that's where the semantic layer really does fit in, is it enables that to happen. And OLAP, or the multidimensional view, which I think is a core requirement for a semantic layer, is what enables that anything by anything type of questioning and answering.
Yeah, that's fantastic. I want to change gears slightly here. Actually, kind of back up in the conversation. So you were just a minute ago, we were talking about the free for all nature of spending in the modern data stack and how that's a huge problem. Ravit Jain put in a question about FinOps, so I'll just pop that up on the screen real quick, and hopefully everyone can see that. So, can you tell us a little bit about FinOps? And I have ideas about FinOps, but you're certainly been thinking about this too. So. It's picking up real fast. How are organizations benefiting from it? And so I'd love to hear your thoughts on FinOps and how that ties in with the semantic layer.
Yeah, I mean, FinOps is like it's sort of an idea where the finance teams and data teams work together to plan out and track their resource spend. So and so what it means is like it means that that it's not only IT working with the business, it's also finance working with IT and the business. And that's like the new part of the equation. Because before, finance was only involved to provision a request from IT or the business, right? The business would generate the need. IT would say, here's the equipment I need to be able to deliver what the business needs. And they would negotiate with finance to go and get that hardware procured and installed. And then it's sort of one and done. And you don't really have a conversation again until the next time the business says, it's too slow, or I need to go and get more data. And so it's sort of it's spiky. That's not the world we live in the cloud, because when you make data more available to anyone, and they're going to ask more questions, and if you let people ask questions with handwritten SQL, boy, you can get into trouble fast, right? And so one of the problems that I see out there with customers is that when they do allow people just to write handwritten SQL, it's you could have a query that will cost you $1,000. You could have a query that costs you $10,000. I've seen some queries at $50,000. It's like it's very easy if you allow people to do that. So again, I come back to the semantic layer, but you want the machine to be generating the queries, because if the machine is generating the queries, it's going to be generating queries in a predictable fashion, which is going to make costs predictable. It's going to, and with a good semantic layer, it's gonna optimize and tune those queries, which means you're going to get a lot more for less money. You're going to be able to throw a lot more queries, a lot more users for the same amount of spend, or even less. So with the FinOps discipline says, let's have finance be able to give finance the tools to give the business a budget for their compute for analytics, and then track that and optimize it over time. So it's a really good discipline. It requires a whole new set of tools to be able to track that. And then it also involves the business in the cost equation. So before, the business didn't care about what it costs, right? Now they know that, okay, if I want this metric every minute, it's going to cost me this much. Am I okay with it having it once an hour? Yeah, I am. Okay, because it's going to save. It's going to be 5 times cheaper. When you sort of allow them to start the business to sort of involve them in understanding those trade-offs, then it results in the right kind of behavior for the whole organization cost-wise. And that's not a muscle that we're used to, but it's a muscle that we need to really build and develop in this new sort of cloud world.
And one of the related comments, so J.R. Storment and Mike Fuller wrote a book for O'Reilly called Cloud FinOps, and I think they're some of the major advocates for the whole FinOps philosophy, evangelists for the philosophy, if you will. In the book, one paragraph in there talks about, well, I think many places, but there's one specific place I'm thinking of where they talk about this idea that FinOps is not just about saving money, it's also about making money. And really it's this idea that you're adopting some almost like supply chain thinking. So with supply chain, of course, you're always thinking about saving costs, but you're also like, well, if I'm manufacturing 50 times more units, then I'm making more money, therefore I can spend more money. And earlier, when you were talking about your experience at Yahoo, you talked about, what was it, like $15 million attributed to the technology you were deploying. So that would be the other side of the FinOps equation, the money you're making off of your data. How did you do that attribution? Because I feel like that's like, a $1 trillion question. Like, how do we attribute value to all this money we're spending on data? I think intuitively, people in business understand the value and they see, okay, we're helping customers, we're improving data science maybe, but how did you go about that attribution question at Yahoo?
Yeah, it was 50 million a year, not 15. So it was
Oh,
even
50.
bigger
Okay,
number than
sorry,
that.
50.
It was even bigger than that. You know what? It was, when you sort of make that investment, what you need to do is you need to be able to measure and you need to have a way of measuring what your return on your investment is. And so before you make any investment, you need to figure out how you're going to measure whether it was successful or not. And for in this particular case, it was about display advertising. And what we did is we took, before we implemented the system, what we did is we looked at what the return to the advertiser was in terms of performance per cost. So performance meaning on the ad. What did the ad? How did the ad return that value? And it depends on what their model for value was. It could be a click, or it could be actual revenue from that click. And so based on that, we were able to see a before and after picture over a certain period of time. And we could attribute that lift to the investment of better targeting, because we could measure that better targeting. And then we can compare the numbers year over year to see what that lift was. And we did that on a continuous basis. But yeah, you have to know going in, how are you going to measure the benefit? One of the things I like, Matt, is sometimes that could be really hard. But one of my rules of thumb is that if people are asking more questions, then what you've created as a engineer, as an analytics or data person, we always look at what is our value to the business. And if I've created like a system that where I can see that queries are up and to the right, that means that people are getting more value. And so what I think when you apply a FinOps discipline, what you're going to do is that you're going to apply and you're going to look at where that value is and where it isn't. And where it isn't is where you're going to look at that and say, do we really need that? And where it is, you're going to pour more investment into what's being successful to make that even more successful. So you can't do that unless you track it. And so you have to have a common way to track that. And you have to track it over different business units. So with things like Snowflake, where you have different data warehouse sizes, one of our customers, what they would do is that they would assign different data warehouse sizes to different business units based on their need. And it wasn't just a one size fits all. Obviously, it was different sizes, but also different sizes over the month. So the finance team may have a small warehouse all during up into the first 3 weeks of the month, but then they would get a large warehouse for the last week of the month because that's when they were closing the books. And so if you have the ability to start tracking things like that, you can make those sort of trade-offs and make those and bake them into your whole architecture so that everybody's getting what they need, but not getting too much and wasting money.
Yeah, here's another example I saw recently with a client. So I was talking to this company, and they had something like 8,000 different jobs that were running just all kinds of stored procedures and such every day. And they were looking to do a cloud migration. And not only do they have to migrate to the cloud, but they have to change, they're looking to change systems, change databases. So these jobs have to basically be rewritten. And so we started discussing like, okay, what percentage of these jobs are actually important? And so we went through this whole discussion of like adding telemetry to jobs, adding telemetry to target tables to see who's actually consuming this data. And I suspect, based on what I've seen in the past, that maybe 20% of these 8,000 jobs are really, really important, and the other 80% either rarely or never actually get consumed because they've been there, just carried forward from one system to another for the past 20 years, just accumulating and accumulating. I don't know if you have thoughts on relating the semantic layer to that as well. I'd love to hear.
Well, I can tell you the semantic layer makes that much easier to track,
Okay.
Matt, right?
Yeah.
Because it's one plane of glass, right? So it's a single plane. It's one sheet of glass. So you have queries coming through it, which means and so you know where they're coming from. So who's running them, why they're running them, what piece of data they're going after, what data sets they're going after, and then the system optimizes the back end on using that data. So for our semantic layer, we'll create aggregate tables in the data platform and then rewrite queries to access the aggregate tables instead of the atomic tables, which saves a ton of compute because you're removing all that I/O, that repetitive I/O, because it turns out that people ask the same types of questions over and over again. And if we're sort of rolling and re-rolling up data over and over again, that's just a waste of resources. So the semantic layer can really truly help with that. But let me give you another example. I'll give you an example of AtScale, actually, our own use. We're on all three clouds because we have to test our software on all three clouds and all these different data platforms. And we went through a process fairly recently, again, hewing to the sort of FinOps discipline. And doing it starts with an inventory. And because there was no process for provisioning resources, it was anything goes. I would say 95% of what was provisioned and running was not even needed because people started running it and they forgot about it. And it's just sitting there, the meter's running and nobody's using that resource.
Yep.
And nobody could touch it because you don't know. And so really, as part of what we did in there, obviously we did an inventory and shut down all the stuff that wasn't needed. But then going forward, we had a ticketing system for provisioning, new resources. And you know what? Nobody likes that because you want to just go and do it immediately. But for this to work, that ticketing system, people need to be on that, and there need to be some resources working on that so that it actually is easier for people to go and provision new resources through filing a JIRA ticket than actually trying to do it themselves. And if there's too much of a lag there, then you're going to get a lot of pushback there, and so you're going to get back to anything goes and get back to recreate the same problem we just solved. So it's not easy, but it does start with the discipline of creating inventory and also having a way to have using telemetry to figure out who's doing what. And the semantic layer can really help there, especially for analytics.
I want to pull up another question here. This one is more related to data discovery, and so I'm curious if you have thoughts on this. So this is Shandon's question, which is that where a data catalog would have helped? So I think we're referring back to an earlier part of the conversation, just thinking about this as we're going to build one soon. And so I think in general, the question is like, are data catalogs useful within an organization for discovery purposes when you have all these different data sources, especially when you're implementing some version of data mesh? And so there's a lot of data out there flowing from many different teams.
Yeah, we saw this. We as a semantic layers as a company, like it was discovery is a big issue. Because how do you know something if you have a semantic model out there? If somebody doesn't know about it, then no one's going to use it, and they're going to go and reinvent the wheel, honestly, on their own. And so what we saw is like an enterprise data catalog is really useful for discovery. And so what we did is we built integrations to tools like Elation and Calibra, and this had a data catalog API that will allow you to build your own around that for that same exact reason that Shandon is mentioning, for discovery. And it turns out that a lot of companies I've seen use the enterprise data catalog as that front door. They use it for their Google search when they're looking for something. So they could say, I'm looking for revenue by SKU with gross margin. And then they can find, in our case, they could find a data model and the connection string that they can then connect Tableau to go get that. Or there's an existing report that already shows that. So I think data catalogs could be very useful for that. Where I think that sometimes people conflate a data catalog with a semantic layer is that the data catalog is it's an index. It will allow you to find that data. But ultimately, you still need a semantic layer to query that data. So I think it's important that they go together. We explicitly chose not to build our own data catalog in the semantic layer because we think that it's better to integrate than for us to try to be the end all. Like, we're not in the data catalog business. We'll go ahead and let our partners do that, and then integrate with them so that they can do more than just find semantic layer assets. They can find other assets as well, like reports and the like, and dashboards. So I think that's how it all fits together. So yes, I think a data catalog does help.
And while we're here, I'll give Ole Banyu a shout out as well. He wrote a book for O'Reilly called The Enterprise Data Catalog, and it's very much along the lines of what you were saying. He basically not only describes how data catalogs work, but he kind of defines this vision of a business where everything becomes searchable, which is kind of true right now, but not yet true in a lot of organizations. And so go check out his book, but it's a fantastic insight into this idea. So. Let me ask you another question. I come from originally more of a data science background. And of course, when I was working in data science, ultimately, most of the problems I was trying to solve came down to data engineering because we just didn't have the resources we needed for that, which is how I got into data engineering. How do we manage the tension between, say, more curated queries that are happening on the semantic layer versus, machine learning engineers, data scientists who really need to do freeform exploration? Like, from your perspective, how does an organization manage that tension between the two sides?
Yeah, I love this question. I love this idea. So, when we started the company, we focused on the business person, the business analyst, and that was the persona that we really sort of really built the product to address. But what we found in our customers is that, like you said, the data scientist was having the same problem with getting access to data. You hear all the stats about 80% of the time for data scientists is spent in data wrangling, and so we saw that as well. And we said, a semantic layer can really help the data scientists to avoid having to do what the business analysts used to have to do, which is basically become a data engineer to go and get the data and put it into the form that's workable. And so what we did is we opened up the data, the semantic layer to that data science persona by introducing Python as another sort of query interface. And it did a couple things, Matt. First of all, it did cut down the time on training models and on building and defining machine learning models because much of the work was already done, or all of the work was already done for the data scientists. You still may need to get to that granular data, and you can run those queries to do that when you're training the model. But you need to understand what the shape of the data is, and the semantic layer really helps there. But what we did in addition to just providing that read interface is we provided a write back interface. And what I mean by that is like, well, what does a data scientist do? They generate new data, right? They generate predictions, they generate new features. And so what we allowed them to do is write it back to the semantic layer in the form of dimensions and measures. So what happened then is that our usage for the semantic layer went from, if you look at the full spectrum of analytics, we started out with doing historical analysis. So descriptive and diagnostic types of analytics. What happened and why did it happen? And that's kind of where it ended when we focused on just the business analyst persona. But when we started to involve the data scientists, now we can do, we can predict the future, right? So then we can go from historical analysis and augment it with predictive analysis. So we can do predictive and prescriptive analytics as well in the same platform. And by allowing them to collaborate and write back to the semantic layer, now we can have the data scientists and the business analysts both working together on the same set of definitions. So there's consistency, but now the business analysts can actually see predicted sales in addition to historical sales, all in the same platform without ever blinking an eye. And they don't even need to know where that predicted sales came from. Just like they don't know where historical sales came from. They don't need to know that anymore. But when you have a semantic layer to unite data science and business intelligence, then you really have a 1 + 1 = 3 kind of a scenario.
And so in a sense, there's a bit of overlap maybe with feature store platforms, but my assumption is that your feature store platforms like Featureform or Feast are focused more on the pure data science and machine learning use cases, whereas the features they're writing back to a semantic layer are more for consumption by analysts in the business.
Yes, that's a great way of saying it, Matt. Great way of saying it.
Interesting.
Yeah.
I have another comment here from user Noam. I think it's Noman about the fact that tools like Power BI had some semantic layer features built in. How do you differentiate from like those more historic tools in the semantic layer space? What's new in the domain? Yeah, go ahead. Sorry.
Yeah, I mean, Power BI is king in terms of how people are visualizing. No doubt about that. And in our customers, we started out being most Tableau and Excel were the most used tools against the AtScale semantic layer. Now I would say it's Power BI and Tableau are neck and neck. Power BI is growing faster. Excel is still there, by the way. So Excel is the #1 consumption tool with the AtScale semantic layer. Still is, and probably will be for the foreseeable future. But Power BI, what is Power BI? Well, Power BI, if you think about it, analysis services, which is what I used at Yahoo, SQL Server analysis services is a great OLAP engine. It's never gone away. It's called Power BI Premium now. So if you're using Power BI desktop and are using Power BI online, and you go and you do an import mode on your data from something like Snowflake or Databricks or BigQuery, that data is going into analysis services on the back end. So Power BI is become a superset, a wrapper around analysis services. And so Microsoft has done a pretty brilliant job of sort of building a really great visualization tool set, and they've used analysis services as their back-end engine. So then how does this all work together? Well, if you're only using Power BI and Excel, well, then that's probably a good solution for you. And if your data is small. So I always tell customers or prospects, if you got more than 20 million rows of data, import mode isn't going to work for you. Because what you're essentially doing is you're taking data out of your cloud data platform like Snowflake, and you're moving it into analysis services. And I can tell you, based on my 24 terabyte cube, where that was stored on disk, now with tabular models in Power BI, it's stored in memory. So that's one of the reasons why I started AtScale is that I was a big partner of Microsoft, and I was telling them scale out analysis services. And then they went and said, we're getting rid of the multi-dimensional model, which is on disk, and going to in-memory because in-memory is the future. And it's like, I can't store 24 terabytes in memory, and that's even 1/3 of the data that I need to store. So you can't do that to me. So what I say to people and where we fit is that if you want to use Power BI because it's a great visualization platform, you can use it with the semantic layer, and we'll support it as the same way that Power BI is supported with analysis services and Power BI Premium. So it's no different. So you don't lose any fidelity in the choice of the tool. But I do believe that yes, that Power BI can be serving as a semantic layer, but it's going to serve as a semantic layer for the Microsoft stack. So if you have data science tools, you have anything else outside of that stack, or you have data in another cloud and you don't want to move data, that's where you want to consider an alternative. And if your data is larger than 20 million rows, it's just a nightmare to move that data and to keep those basically those cubes behind the scenes up to date. So nobody wants to build cubes anymore. And we sort of have now pivoted back to building cubes. And maybe it's not called that, but when you do import mode in Power BI Premium, you're building a cube. And that's just the fact.
No, this makes a lot of sense. One of the things I've read about the history of BigQuery is that early on they realized that the key to really good data performance was to basically bring the compute to the data, so you're not moving data all over the place. And it sounds like you're basically applying the same philosophy here. You're building a semantic layer, but everything is pushed down into someone else's platform. So you're not reinventing the wheel, and you're not shipping data all over the place. And there's still this opportunity to maybe do some limited in-memory queries where you need ultra-fast performance, but it's not scalable. So.
Yeah, and you know what? And we solved that with the combination of aggregate tables, and then those aggregate tables can be pinned in memory for ones that are used very frequently. So we can get sort of that sub-second performance that's required for tools like Excel and for a lot of people who need to get a query back in under a second. So you don't have to go back to building cubes. Again, it's like, I built cubes. It's no fun.
Yeah.
It's no fun, and it felt wrong to me, but it was the only thing I could do at the time because there was no other technology to make it possible to leave the data where it landed. And to me, I tell everybody, you can have your cake and eat it too. Don't move data. Moving data is evil. Creates all kinds of really bad side effects that you just don't want to deal with.
Yeah, no, that totally resonates with me. I mean, from my perspective, even though we need semantic layers maybe more than ever, there's a reason that the actual technology of cubes, that version of OLAP technology is slowly going away, I think. I mean, it still exists, but it's not front and center like it used to be 20 years ago.
Yeah.
We're getting toward the end of the hour here. What else is on your mind? Anything else you want to talk about before we close out today?
Oh, it's like I think we covered a lot of ground here. I think that there's a lot of interest, and I talked to Bill Inman about this as well. He has a perspective on this whole sort of lakehouse versus warehouse kind of argument.
Yeah.
I don't know, Matt. Have you been following a lot of the sort of fighting going on between the vendors when it comes to lakehouse and warehouse?
So I'll tell you, yes. In fact, I was using a certain Spark-based platform when they announced. Frankly, I don't think they were using the term Lakehouse yet, but I was there during the inception when they released this early. We were kind of an early tester, and they released this concept really of building a data warehouse on your data lake. So I'm familiar with the arguments, I'm familiar with some of the strengths, and I'm familiar with some of the problems. So I'd love to hear your take.
Yeah, what's interesting is that I was a real skeptic when I heard about the Lakehouse concept. And well, now that look, everybody wants to have it. To me, that would be my preferred architecture.
Yeah.
The problem I had is like I've spent years running Spark on external tables, and it's just for BI. And we made it work. We do make it work for a set of our customers. It's just not pleasant. And it's hard, and so it felt like it was there was a missing piece, and that the missing piece was really an analytical engine that could really run as an analytical engine on the data lake. And I really hadn't seen that. And Snowflake, and just really benefited and prospered as filling in that role. And then, you know what, I could say that, working with the Databricks team on their Photon engine, for the first time, I think it is feasible. It's more than feasible. I think it's an architecture that people should look at. So I've come around to being not skeptical and thinking that, hey, a Lakehouse type of architecture is achievable. And if you think about it, if you're somebody who hates moving data,
Yeah.
I hate moving data into a warehouse, dude.
Yeah.
I mean, that's like, I don't want to do that either. But that was what was necessary. So if we can get away and we can get the same kind of performance without having to reformat data to make it fast enough for analytical queries, then why would we? And so what I would just tell people is like, look at the Lakehouse sort of architecture, and look at the tools in the ecosystem now. Take another look if you dismissed it before, and try it out on your own. Because especially if you're migrating to the cloud, it simplifies things drastically to not have to move data twice. Once to the data lake as in the form of a file system, and then from the file system into a proprietary data format to support analytical queries.
Yeah, and the comment I'll add goes back to our discussion earlier about the tension between the needs of analysts and the needs of ML and data science. And that is that often with the traditional data platform architecture, the ML scientists kind of get the short end of the stick. In other words, they have to then pull their data back out, move it into some other tool to be able to write the kinds of queries in PySpark or something that they need to do. And so that's where the Lakehouse architecture really shines, is that you can basically serve both needs on one platform. My other comment is that I think where Lakehouse platforms have struggled, and they've made up a lot of ground in the last year even, is in making the easy stuff easy. So what do I mean by that? Well, often in the Lakehouse, stuff that's just table stakes, really basic in a data warehouse or MPP platform, like column level access control, user permissions, gets hard, right? And that's what's always caused these initiatives to stumble. And so if you can get that stuff right, then you can really serve both sides of the house well. Just get those basics, all the permission control, all the simple DML, DDL, all those things.
Absolutely, and that's when an enterprise looks at that technology, and they try to do that bake off. If it's not there, then it can't serve as a data warehouse, can it? It can't serve as an analytical data warehouse. Exactly. So those features have to be there. And I think that the Lakehouse vendors know that, and they've been they've been furiously adding those features to get the parity there. And that's why I say it's like, if you asked me 2 years ago, no freaking way. You asked me today, it's getting close. If it's getting close, if not already there.
Yeah, they've made a huge amount of progress, and so it's funny to look at the evolution from the days of pre-Hadoop through the kind of cloud MPP revolution into maybe we're headed really towards the cloud data lakehouse revolution, where these tools will really start to grab a lot of ground in the space.
Yeah, Matt, what I love about I like the idea of you have a single data store, and then you just apply different engines to it. Exactly. And the engine, you use the engine that's most appropriate for the job. And the engines for data science are going to be different than the engines for analytics. That sort of pattern makes sense to me. So that's why I like that idea. I don't like the idea of taking data and then recopying it and then storing it and reformatting the data for different engines.
Yeah.
I don't like that. I like to have different engines running on the same data. So if we can get to that point, then we're going to simplify things drastically, and also be able to manage costs and be a lot faster at introducing new technology to the business to allow them to answer those questions.
I think at some point the technology evolved such that the difference between Snowflake and Spark was no longer scale of performance. Like you could use either tool for big data, both perform extremely well. It more came down to how programmable do you need your queries to be? Can you use a set-oriented language, SQL, coming from math, I like to talk about set theory. Or do you
Hmm.
need something that's highly programmable where you can program your own steps in a DAG and then you need to go to Spark? And so if you can do that all on one platform, it just makes your life so much easier and you get away from the evil of moving data, like you said.
Yeah, for sure, for sure.
Well, thank you so much for joining us. I think we'll close out for the day, but yeah, this has been a very insightful conversation. I've really enjoyed this discussion and look forward to interacting with you in other contexts in the future. Next week, we have Tim Berglund joining us. And he's from StarTree, and so I think we've kind of had this semantic layer theme for a couple of weeks, and so we'll just continue on from there. So look forward to seeing you on LinkedIn and other places, and thank you everyone who's joined the show.
Thanks, Matt, and thanks everyone for listening.
Take care. We'll talk to you next week.
Yeah.